This video is going to be to explain a little bit about serial plug-in ModBus. As I've shown before, when you have Mach 3 running, you have a serial ModBus with 128 16-bit input registers. You also have a TCP ModBus with 1023 registers for input. The serial also has 128 registers for output, and the TCP also has 1023 registers for output. So each of the serial and the TCP ModBus have buffers. Each one is a different length. But there's a third type that we hadn't discussed, and that is serial plug-in ModBus. The reason it's called serial plug-in ModBus is because the data is organized so that a plug-in can easily get and attach to the data so that it can use it in various ways. Brains, though, operate similar to a plug-in, so they also have access to it. The configuration of the buffers for serial plug-in ModBus are a little bit different. Remember that we have a PLC, which approximately 10 times a second, or whatever the refresh rate is set at, transfers data in and out of the serial ModBus area. TCP ModBus operates inside the TCP buffer area. Both of these are PLCs sending and returning data. The serial plug-in, however, has configuration areas, and the configuration areas are from 0 to 63. So there are 63 of these, and each configuration area is set up with a start address in the PLC to start transferring, a time of refresh, say 25 milliseconds as default, and whether it's an input or an output, data for the protocol involved. Most of this data is unimportant to you, and all you'll really be using is the address, the time, and whether it's input or output. Let's say, for example, that we know that in the PLC, address 100 is a count representing MPGs. We set up configuration 0 with address 100, refresh every 25 milliseconds, and say it's an input. At this point, every 25 milliseconds, the address in 100 will be sent to a buffer, which is in every configuration area, and the buffer is 128 words long. By default, every time you transfer something into a configuration area, the first register goes into word 0 of the 128 words. If you tell the configuration that you're going to transfer 7 registers, and you started at address 100, then the PLC will transfer from 100 to 106, that's 7 registers, and transfer them 0 to 6 inside this area. If you watch the brains and MPGs, you'll then see how to get any word or bit of data from any one of the 63 configuration areas. You could, for example, have configuration 0 set up to transfer those 7 bytes, or those 7 words, at a 25 millisecond interval. We could then say that on configuration number 1, that we want to start at address 107. We want to transfer every 100 milliseconds input, and we want to transfer 5 registers. This would mean that in configuration 1's data buffer, each configuration has its own data buffer. In that data buffer, address 107 in the PLC, all the way up to 107 plus 5, so address 112, will be transferred into the data buffer of configuration 1 starting at address 0, 1, 2, 3, and 4. So if you're programming a brain, you know which configuration, the one which is specifying the data coming in, and you know to grab it in the first 5 memory locations since you're only transferring 5 registers. These don't have to be contiguous areas. Each configuration could just look at one register, for example. So you may want to transfer address 100 in at 25 milliseconds, but maybe address 101 you want to transfer in every 100 milliseconds because it's not as important. Using this method of timing and selecting which registers are going in allows you to set a priority for the data which is coming in. The same thing works in reverse. You can set, say we set configuration area number 5 to start at address 120 and to go every 25 milliseconds with output for 5 registers. This would mean that in the data buffer for configuration 5, we're going to take 5 registers, 0, 1, 2, 3, and 4, and every 25 milliseconds, we're going to transfer them to the PLC at address 120. Therefore, these 5 registers, every 25 milliseconds, will scoot up here and be put into memory address 120, 121, 122. You get the idea. So this configuration of serial plugin is somewhat more powerful than the old serial ModBus. And if you're not using special processing with a ModIO, it may be the way to go, or if you want to design your own ModIO plugin. The weakness here is that there's no way yet to send a string to the ModIO, so you can't use the LCD display on it the way that you can with the old serial ModBus. The old serial ModBus, by the way, when it's sending data back and forth to Mach 3's serial buffer, it has a break in the transmission called ModIO processing. And in ModIO processing, if you've told Mach 3 that you're running a ModIO, it will take the first address, which is register 0, and stick it aside as an MPG value. It takes register 1 and breaks it into 8 single bits and uses each of those bits as port 0, pins 0, 1, 2, 3, and 4, for example, etc. There is special things done to ModIO traffic just for that device. That's not done here in serial plugins, which is why you would need brains if you wanted to deal with it. The upside here is that it doesn't need to be a ModIO anymore to send MPG data in. If you have an MPG and your PLC is capable of keeping a simple count, you can use the brain to send the MPG data through your brain into Mach 3's count register and use an MPG with almost any PLC. All right, I hope this helped. I know it's a bit confusing, but I imagine it will all come together in time. Thanks.